And today we're going to talk about S3. Awesome. Um, all right, so uh, the S3 classes are first and simplest functional object-oriented programming system that you heard of in the last chapter. And so now we will try to recognize S3 objects and classes. I'll go through assigning S3 classes to
We
objects.
don't, we haven't seen the um things move. I think we're seeing the wrong screen.
Hold on, let me stop it. My mistake. Let's see.
We can start if you would like, or just have a little bit of a hiccup.
That's okay.
There we go.
All right, cool. Let me go back.
I think when you go full screen, we lose it.
Oh, okay. So I won't do that then.
Um, you should be able to, but I don't know. We saw the menu that said full screen. That's what we saw the whole time you were.
Yeah.
Oh,
Okay. So I guess it wasn't working. I'm happy to leave it here if that's okay.
sure.
Um, yeah. Okay. So, yeah, we'll recognize as three objects and classes. We will try to assign as three classes to objects. We'll go through creating as three generics and methods, and then we'll look a little bit at implementing advanced features of S3. Okay, so what is an S3 object? Um, Really, it's just an object with a class attribute. So if you look at a factor, and you look at its attributes, and there's a class, and here it's called factor. If you look at other objects, most of them, many of them also have a class attribute, making them an S3 object. S3 generics provide an interface to a particular behavior. What that means is that, like, say in the last example, a factor with a class factor, um, that will determine the behavior of certain functions. Um, Functions that are called generic because they are customized to different object classes. Now, one of the biggest examples is the print method. That's an S3 generic for displaying objects depending on the class attribute. And so here you see that um, print as an S3 generic. If you look at the function body of print, and we'll talk more about it later, but it just says use method print. And you see here, for example, that when you give the factor to the print method, it looks at the print method with the factor behavior first. And so here we saw the print behaves differently depending on the object class. And so like F here is a factor. And when we print it, it looks and shows the character levels with the vector in this format. If you were to take away the class attribute by unclassing, like here, then it's just an integer. And then if you use print, the actual printing looks different. Right, you see that there's an attribute called levels, but there's no class here. If you want to look at the function body and how factors are printed, then you can either use the nomenclature, we have the method, print, the generic, then dot, and the class name, so print dot factor, or using this loop package, S3 get method, will show the function body and its code. So you can see that there's a lot of code that goes into just printing a factor. And that's sort of, and we'll talk more about this later, it's sort of hidden to the user, for doing such a simple task. And that's one of the things that make S3 so powerful. All right, so how does one create an S3 class? So we assign an S3 class to a new object with the structure function or assigning the class directly. So here, like as an example, you can give a list, an empty list to structure the first argument, and then assign the class argument anything you want. But if you do that, anything you want, like my class, I mean, it gives you an S3 object, but currently it's pretty useless. So how can we make this more interesting? All right, so Hadley recommends creating a new S3 class with three functions. And I don't want to say just Hadley. I think the whole community agrees with, these recommendations. So first, creating a low-level constructor. That would be the workhorse that efficiently creates new objects with the correct structure. But then you want to make sure that it is correct. The object does have the correct structure. And that's where the validator comes in. It performs maybe the more computationally expensive checks, but ensures that the object you're creating has the correct values. And then what you want to give to the user is a user-friendly helper function that really makes it convenient to create objects from your class. And so the example in the book, like here is like creating a new factor. So you can create a function called new factor that creates the S3 object. This is developer facing. Um, that's for the developer who writes the code to create the object with the correct values. So here you see that there is like two small checks, but really you show that it creates the object as intended, as but I'm sure you can see that you can create the use this function in an appropriate way that errors out. Like if you give a vector 1 to 4 instead of 1 to 3. And that's where the validate factor function comes in. This provides assurances on correctness. And as I scroll through the function body, you'll see there's, well, here just two, maybe they're computationally expensive, maybe not, but two checks that would ensure correct values so that you can insert this function before you would, um, return the object to the user. And so the last um, function would just be the convenient helper function for the user to use. Again, it provides a safe approach for users to create objects. And you see that it both involves the constructor, which is the developer-facing function, and the validator, to make sure that what's created has a correct object structure, for a user to use. Because though it's a simple creating a factor, we all like read a lot of code that relies on, having correct objects. And so this is really important, especially making sure that a whole like script or a pipeline or whatever it is runs as expected. Here's some example S3 classes in the wild, quote unquote, not use the recommended interface. And here I just looked into two commonly used packages. So in the Tibble package, you create the Tibble class using these three different the constructor, the validator, and the helper class. And we all love Tibbles because it has a print generic that shows a data frame in a very user-friendly way, and that's afforded by the Tibble class and its generics. Then next we have an example from dplyr for making a grouped data frame that we often use when transforming data sets. And I'm sure there's many others out there. I didn't look I didn't cast a wide net. Right. So how do generics perform dispatching? And what does that mean, dispatching? Well, we saw with the print method, we had a print that factor, function. And dispatching is really making sure that that's called. So to give a concrete example, the summary generic that kind of behaves based on the objects class. And so you see it in your print, the summary generic, the function body has a use method function. But as you can see below that, there's a lot of different I guess there's many dispatches provided when you for the summary generic. So when you run an ANOVA, you run or you just have a data frame, or you have a date, or what have you, that there's a particular generic that will summarize that object in a very particular, hopefully user-friendly way. And that when you give an object the summary generic dispatches to the correct method. And that's all done for the user. The user doesn't have to like think terribly about where the summary should come from. So that's really useful. And so, like we saw, that summary is the interface. It is an interface to the different methods. And formally in computer science, and what we heard about last week too, is that this is polymorphism. So providing a single interface to different behaviors. Um, but one drawback from this summary generic is that it doesn't have a consistent output class that we would expect at least. So here's an example where you have the vector of the sepal lanes from the iris data set. It's a numeric vector, and when you summarize it, it has this familiar, box plot summary measures. And the class assigned to the output is a summary default in table. But if I were to get a factor from the species column in iris, and I summarize that, then I get a nice looking summary telling me how many species I have but the output, the class is different. It's integer or numeric. And so if you were to try to feed that into something else, you have to be very careful. You have to know exactly what you're doing. There wouldn't be dispatching. Um, you know, there wouldn't be an easy way to pass this along. And so we would like to have a consistent class given if possible. So I made this custom summarizer as through generic just for the presentation. That would output a consistent object. I don't know if this is useful, but this just gives the point that you could do this. And so here the goal of the summarizer generic would be to summarize characters, factors, or numeric outputs, and always give a length one character object. And you would do this in the real world for people to use. Your generic only write the method if you own the generic. Otherwise it's considered bad manners. I guess it makes sense. Because that's usually given in like a package, and you kind of want to make sure it aligns with the vision and the purpose of the generic. If not, it can cause downstream issues for a lot of people in unintended ways. The second rule would be the method must have the same argument as its generic, just for consistency. And with the exception, you can pass dot dot dot. This allows you to, accept arbitrary arguments. And that may be useful, especially in a complex pipeline. For example, Shiny app. And so, the, when I make this S3 generic, here I give it two arguments, so the actual object X, and then I have this probs argument. That's no, I guess gonna be used by the use method function. Um, and here I just put the little blurb from the chapter that how use method works. I think we learned from the environment chapter that use method, when we learned from the environment chapter that there's a caller environment in the function that exists, use method actually captures that. And so whenever you have an arguments in the function in line one, those are captured in that caller environment, and that's available in use method, and that's what's given to the actual method downstream. For more details, though, you can see the help page for use method. It's kind of interesting. Yeah, but we'll just show how this might be useful, if at all. So, again, the goal is to have summarizer output consistent summary strings. So I have a couple of different methods, one for characters, and you can see here, just output and paste together some things into a string for like any numeric types. And you see that it puts again a string, paste some things together. Um, for any like factors, it'll use say method for characters, but convert the factor into a character. Kind of dumb. You would do this probably in a different way, but just think of an example of having consistent outputs. That's what's used. Then you want to have a default in case that your generic doesn't have a method for a particular class. You want to fall back onto something, and that something is usually just default. So here, the default is a string, but it says no summarizer method for this class. You may want to do this in a different way, but uh, it gives a consistent output. If I were to apply this generic onto vectors, you see that, yeah, it does what it's intended to do. It outputs a one length character vector, a string, you know, in different ways. So that's a good thing. Whether they're good summary strings, you could be the judge, but they give it a consistent output. And then you could use this in a data frame as well. Good. Pipe iris into the field apply when we learn that it's a little bit safer Bazar apply method because it ensures that we're getting a one length character string, which it is. And so that's kind of nice. And you do the same thing with another data set, like the log data set from the survival package. And here, it goes through every single column, and I'll put a one length character string, summary, as you can see. So that was pretty simple to make a generic, pretty powerful, but you can also see like there's ways of abusing this, and it can get you into um, you know, deep rabbit hole you don't want to be in. Like something I would change. Um, I wouldn't summarize in this way, you know, but I also make sure that the class is actually given. Like I make a class, I didn't make one here. But again, you can see how easy it is to make an S3 generic. You see that, why we define a default, like a fallback almost. The cool thing about S3 generics is that the next method is used when you're missing summarizer generic. And this actually highlights the concept inheritance, where they give this example. You see that I'm summarizing like factor, here. But I'm then adding a custom class, my class. I'm adding it here. But the great thing about the generic is that though the my class method doesn't exist for summarizer, the next method or the next class factor is then recognized and then the method for factor is used. So that's kind of a nice um, thing. Yeah, if anyone, I know the chat's going on. I'm happy to stop if anyone wants to highlight certain things.
I can just summarizing the couple of things that we talked about in the chat. Asked or pointed out that usually print would be the next function after the uh, creation functions. That you want a print method. Something like this edition of Advanced R came out slightly ahead, I think, of the vectors package. And it's another one where all the stuff he talks about in this chapter of like best practices, they made a package that basically is those best practices. And so it has methods for making vector-ish classes. So if you have something that is, that goes into a table, basically. And if you do it with their methods, they use for both print and str under the hood, they use format. So you just need to make a format method and then you get lots of things for that. So anyway, that's a whole thing. And then Stas was also asking about like validation of inputs when, like if you have a method for your class, basically should you confirm that the thing coming in really is your class, not just pretending to be your class, because you can give anything a class. And I was
Yeah.
saying I generally just check the class. If someone breaks it, that's their fault. So they can, they won't be surprised by weird errors, probably. Like, so there was that discussion. Uh, and then yeah, a little bit talking about next method for like hierarchies of classes. If
Mhm.
you have, if you have a whole set of things, um, sometimes next method makes sense there. So
Yeah.
yeah.
Yeah, I feel like S3 it's a gateway drug to a lot of other things.
Yes.
I think it's great. All right, cool. All right, so let's cover some advanced implementations of S3 classes. 'Cause I think it gets back to some of the concepts we talked about. One of the cool things I didn't realize, but it totally makes sense, is that S3 classes can, I call it conceal data elements from like the length, method. I think this is also a generic, if I'm not mistaken, for concise representation. Um, I won't read the bullet points because I took it from the chapter, but essentially, you can have an object that has like 12 elements in it, but concisely represent it in a nice form, like you see below. Like if I have like a POSIX LT object, that looks like, I don't know, January 1st, 2020, and I have a vector of these things. If I call length, um, you can see that there's a lot more elements when you take out the class than when you leave it in. Um, uh, but I think if you make a method for length, that allows you to conceal details from a user for making a specialized object. So again, you want to put an interface that's user friendly, then maybe hide some detail, but still provide that detail to lower developer facing, like code. But for the user, it's nice. It looks nice. And it would have a certain behavior that you may want. Hopefully that makes sense. I hope I didn't butcher that. Um, and next we'll get to the next method. I know we're going to talk about that. And that delegates the dispatch behavior for classes without explicit generics. And so an example from the book is if you make a new class called secret, this generic just mass the actual values with an X. So like if we give that 15, Then you get two X's. Given a 456, you get three X's. Um, this is, you can see this may be helpful somewhere. Um, but there's unexpected behavior when you don't make a bracket generic for your class. And you see that when you think you're bracketing the first element of, y, which we give it 15, you would hope that it gives you, 15. Or, sorry, you hope it gives you XX. That's what the user expecting. But you see here that without the generic made, then you get 15. So the next method defaults in, or it went to the next available method, which means that you should make a bracket for your secret class. Or sorry, a bracket generic for your secret class. And you see that it's an efficient way to subset this class. And one of these things is that you don't get in the book it shows an efficient approach that essentially made an infinite loop. Whereas here you can use the next method in this generic for bracket generic so that it does the subsetting on whatever object you gave before the secret, and then it makes a secret class on top of that. And so you see that when you actually bracket or get the first element of y, it actually gives what you expect, which is XX. So that's a pretty clever usage of next method. But if you didn't use next method, then you may try to use this approach, which copies X and then makes a new secret when try to extract an element. And when you do this, you're getting into an infinite loop because you're bracketing or the function or in the method of bracket. And so you're just going to keep calling it again and again. Whereas when you use next method, it doesn't have that property in which you get the object. And then you make a new secret class. And then you get into this infinite loop. So that's kind of a new trick. Kind of a cool trick. Um, Another implementation is that S3 classes can inherit generics from the superclass or the class that's that's broader, so to speak. So here, for example, we can have we can modify the constructor to um make a class, a new class like super secret, for example, but also have the superclass called secret. Or you can also call that the broader class. And you'll see that lets you inherit some cool behavior. Um, Again, you want to make sure you own that superclass constructor. And so when you create, you know, that subclass, which in this case is super secret, then you give it the class super secret to the new secret, constructor, and that's a pending super secret and secret together. And so when you make or not so, but again you can see like for this class now it gives you just 5 x's in a row for every object you give it. But let's say when I try to get the first element of x2, what's that gonna do? And and by doing this, using the vectors package, like John was saying, vectors allows for using some advanced implementation of S3 classes because there's no way in base R to properly delegate methods in a I call it an inheritance chain. You know, because we have like super secret, and that's a subclass of secret. And both of these classes have generics, but one generic would be missing. So in the super secret, I can make this function that allows me to, you know, use the superclass constructor and allows me to use the generic of that superclass for my subclass. And so when I, you know, try to extract elements from X2, like below, I won't see the actual objects that were given before making the class. I'll use the generic from the superclass, this subset, and show it like here. And so this fact restore function from the vectors package, it provides that proper method chaining. I think it would be really helpful to make a diagram, you know, for yourself. Like it takes me a little bit to wrap my head around this, you know, but if you make a diagram and like show this inheritance chaining, then I think it will make more sense how you would use and where you would use the fact restore function. I think this is my last slide. So I'm happy to talk more about this with you guys or anything else.
Some, thank you. We have any more questions? I don't think anything to discuss. I don't know. Does anyone else have more things to discuss? Um, I'm
I can
curious. Oh, go ahead.
I was just gonna say how I've done this in my work. Kind of a super simple example, but I made a custom generic just for using internally for like extracting most option. Go back if I need to. But for extracting feature importances from you know, in a standard way from like we all know the broom package, you know, the tidy function. I maybe I should, but I'm not making a method in broom directly right now.
Mm.
But for like an internal package, I have a generic that, you know, is particular for that package that makes the same standard output. That uses broom for like LMs, GLMs, those models, but when you come to like tree-based methods, the what's it called, the FIP or the VIP package is often used, and I just made a generic thing sort of encapsulates that logic and make sure that it returns the data from the class, like the same kind of standard columns. So then when I downstream functions, you kind of know what to do. It's sort of hacky, but allows me to write like 5 lines of code instead of like 20.
For sure. Looks like Stas has a thought.
Yeah, so yeah, this is a style question that Hadley is not addressing. So what's the balance of how do you make decisions whether something should be the underlying component of your class object versus the attribute? Because you can hang attribute onto anything, and every time you look at the structure of, I don't know, GLM objects or other objects, you see there are some list components that you're, well, some components of the class that you extract with the dollar sign, and there are some that are attributes.
Mm.
So
Right.
the task that I have is I have, like, that's the comment that I made about hacking length, is that I have a statistical process that deals with two data sets. So basically in that process, I'm cleaning the first data set, cleaning the second data set, combining them, running my statistical analysis on them. And so along the way, I'm attaching attribute either, well, I start with those two data sets as two components um, in the class, but as I go along, I attach, I don't know, R squared of the joint regression or something like that. So I can either say, well, this is a field in the original structure, which is initialized with a null, and is filled later, or I can say this is the I want this to be an attribute that I can define later, and I'm not obligated to deal with. So it's marginally more cumbersome to deal with attributes, right? So it's faster to write dollar whatever dollar field rather than ATTR blah blah blah, more symbols to type. But on the other hand, the validators are going to be failing if it says, well, this is a null value and I'm not liking that either. I need to have some special tricks to process those early stage values. Anybody have any comments? Attributes versus structure components.
I mean, it depends on how you're going to use the object, but I tend to try to make it where like um normal usage is the object, and then if you need to know some weird, something about that object, then that's an attribute. Um, so, it is a little harder to get to. So make sure it's something that you don't always have to get to, because if you're constantly having to do something special to extract that, then that's a pain. I can't think of great examples to to talk out of when I would use either. Like I think it's so case by case for me, it feels like. Um, so yeah.
Hmm. You can also think maybe and maybe this gets back into the copy on the copy on modified behavior. Um, how this works when you modify like an attribute, that it's like a environment where you can modify employees. But in that case, you want to maybe think about, if you're just accessing, that's fine. But if you're writing to something, you consider that, it's like a performance bottleneck, potentially. But I like what John said, like, what's your, like, of the thing, not to be makes sense. But downstream, how are you going to use that? And what's most intuitive for your users? Like my team, they know data sets. They don't know. They're not really R programmers. they're not gonna know there's an attribute of an object. So like I wouldn't like give a lot of attributes. I would try to make something into a data set. Because they're gonna want to plot things. And that's how I do it. So I think it depends on who you're supporting as well.
Yes. I know, like, early on in using R, there would be, it would be confusing of clearly this object has more going on and I can't figure out how to see it. It's like, I didn't understand the whole, well, I didn't understand print methods that you can hide things when you print it, like, and then didn't understand attributes. So learning STR to like really dig into an object, that was very useful.
Well, so I think some classes drag the whole environment. So I think it was some machine learning, probably R part, or some other package that I was working with, where when I run object size on that thing, it says me, oh, it's like it's 50 megabytes. But when it gets loaded from the RDS file, I see that R has to take 20 gigabytes of memory, which is like, you're lying to me, or somebody is lying to me. And I look at the STR of that object, and it says, oh well, this thing and that thing, but well, they don't end up together to, to 20 gigabytes.
Hmm.
Is that an example where things are hidden? I know I don't have a
Probably,
reproducible example
like
for that, but that's
the other
that's
way
a
that can
problem that I
happen.
have. 20 gigabytes is a fair amount of
Yeah.
memory. If I need to load 5 of those, then my machine jams.
So I think we'll probably talk about, um, I'm sure we're going to talk about external pointers at some point. I'm trying to remember where that comes up, but that would be my guess, is that those objects are mostly kind of outside of R. And let's see. Yeah, well, we've got some C++. Oh no, it's pointers. Anyway, we'll see if we talk about that. But that would be my guess, is as far as the R handled piece of it, it's one size, but then that R object is pointing at a thing that is being managed in C++ or something. And I haven't done enough work in that area to be able to explain it well because I don't fully understand it. That would be my guess. And yes, that can be super annoying. You're like, there's clearly more going on here. What is this? So
Mhm.
Yeah,
Well, yeah, so those are the machine learning libraries that are written in Java, I imagine.
yeah, yeah,
And
yeah. So even more so.
Mhm.
So yeah.
Yeah,
Uh
and then when I ask R about object size, it sees the R part, and there's other stuff that goes somewhere
yes, exactly right.
more on it, and that's probably stored on the disk. It's not very sizable on the disk either, but if it's like a sparse matrix that's expanded to the full model matrix, then that's the recipes for disaster probably.
Hmm.
And yeah, it isn't always that it's the disk size. It can be that it's the size in RAM outside of R. And it gets really hard to find those sorts of things. So yeah. I think we have S4 next week, I believe. Let me get this loaded up.
So are we gonna talk
Yes,
about S7 or is it out of scope?
we are
Because
going to. I'm adding a chapter or whatever
Awesome.
a week. So we're going out of order for the next little bit. Next week we're going to do chapter 15 rather than 14 because that way we can do S4, And then once we have S3 and S4 under our belts, I'll do a week on S7 on the 25th. And then we'll do R6 because R6 is different. R6 is encapsulated versus S3, 4, 7 are this generic method type of object-oriented programming. And yeah, then the only thing we have left at that point is the trade-offs chapter. So it's looking good. We've got again, everything is covered until into January. We do still have 2 empty slots. We have where is it? Translating R code in chapter 21, and then we have rewriting R code in C++, chapter 25. Two kind of similar or related topics. And if no one takes them, I can always take them, so it's no big deal. I guess we got at it of, I was, curious to hear, and I would, I'll be curious to hear more in Slack of just how much people knowingly work with S3. I don't like, you work with S3 if you're using R. You might not know it, but you're working with S3 all the time. But it took me a while to really kind of embrace, oh, you can do all kinds of fun things once you understand how this works. Yeah.
But John,
Right.
kind of
Yep.
distant question. So is there a space to talk about C++ classes as they relate to R classes? Or is it way, way, way outside of the scope of this
Well,
book? Well, I have
oh,
selfish interest, right? So I'm trying to revive a package that was written 10 years ago in C++, and it fails somewhere in the interface of passing its C++ classes into R based on the error messages. Fun thing. So there's something changed in R over the 10 years that
a lot
this
of
code
that's
breaks.
fairly recent. If you watch, like right now, I happened to load up the CRAN page for vectors while we were talking, and it has issues that need to be addressed in the next 2 weeks. Here, let me paste that.
Or it's going to be removed from CRAN.
Or it's going to be removed now. That's not going to happen, but it is getting. And if it does, like, you might not know it. You might think, "Oh, I never used vectors yet." Vectors is one of those
Yeah, right.
workhorses of the tidyverse. It's under pretty much every, like, if you look at the reverse imports, it's pretty crazy. And so, like that one, what it has for the check results is stuff about the pieces of the underlying API for how R, like the compiled pieces of R, you can reference those in your own functions. And people used to be pretty messy about it and would reference things that aren't technically like documented pieces of the R core. And they have started to kind of close up some holes because it makes it hard to develop R if people are referencing things that are under the hood but not not documented. Because then you have these things that they're just implementation details, but people are using them. So anyway, they have started to enforce some things around those, and I'm pretty sure that's what's going on in vectors right now. And those same things are very possible of what's going on for you, or things related to that. And so, but so I think back once we get into the final chapter and then the add-on final chapter that Ella is going to present. So the last chapter in the actual book is rewriting R code in C++. Ella is going to put together a C for R discussion because she's worked a lot with the effort of like getting contribution into base R. And then Nick is signed up for Rust for R and then hopefully we'll do a Q&A. I have to actually line that up. Yeah, those last chapters are going to be interesting. I haven't I have done a tiny bit of working with C++ and R. And it's especially Rust would be something I want to learn more. So
yeah, Rust is gonna be a trial by fire for me.
yeah, excellent. That's the way
Yeah.
to do it. Yeah, it's the same. I've worked with S7, but it's been a while, so I'm looking forward to in 2 weeks, hopefully a little bit before 2 weeks from now, getting back into it and reviewing everything so that I can share some notes about it.
Cool.
It's
Yeah,
still
make
S3
a
is
PR
so
to Hedges
easy.
book.
Yeah, like just relatively speaking, the way you work with S3, like there's no structure to it. You can just do it, like, which is what is bad about it, but it's also why it's just super easy to just say, I'm just going to make this function that has use method, and then I can easily, make a generic, make the methods. No muss, no fuss. It's so easy to do. I can just slap a class onto my things earlier up in the chain, and then they'll go to the right piece based on that. And I can take out a whole bunch of like if then type logic. But S7 lets you do safer things, and you can do things like double dispatch, where different arguments in it to make you go to different functions, like different pairs of arguments can make you go to different methods. Just all kinds of fun stuff. So we'll talk about that in a couple weeks. But it is 1 o'clock, so I need to run. I will see everybody on Slack, and I'll see you next week here.
Thank you. Good to see everyone.
All right.